times 10 to the power 6 minus 91.465 times 10 to the power 6. Okay. So this will be equal to 0.3. Okay. This is not 0.3, my bad. Okay. Why this is not 0.3 is because we are looking at this distance from here to here. Okay. So that distance from there to there is 0.29. My mistake. So if I take 0.113 plus by 0.176 is 0.113 plus by 0.176. Yeah, it's equal to 0.29. My silly mistake. I do apologize. It does not make sense not to be right. Okay. So this is 60.797 plus 91.465. 0.29 divided by, so it's 1.905 times 10 to the power minus 3. Okay, so now this is 1.905 times 10 to the power minus 3. 1.905 times 10 to the power minus 3. Now, let's see where I get it. 1.905 power minus 3. That's 60.797 is equal to, wait, 0.11582. Okay, so 0.113 minus 0.11582 is equal to minus 2.82 times 10 to the power minus 3 meters. Okay. So because of the rounding that we have done, okay, because we did some rounding. So by using this method, you got 2.82. Okay. If you use this method over here, you get 2.588. Okay, so they are not that far away. If you look at it, it's about what? 0.5 power minus 3 minus by 0.8 power minus 3. The difference is 300 microns or 0.3 times 10 to the power minus 3 meters. So it's very similar. Okay, so you can also use this technique to determine your position of the neutral axis, but like I make the mistake over here, you have to be careful of the delta y. I made a mistake because I took the entire cross section. Okay, right. Fortunately, that could be solved. Any questions from anyone from here? Anyone, please? Okay, I don't hear anything. So the next or the last topic in bending moment that we're going to look at, okay, is going to be on eccentric unsymmetrical bending. Okay, so this is the last topic we're going to look out for in bending. So you have this figure. Okay, you have this figure on Avenue to Learn. So what you see is a structure under eccentric unsymmetrical bending. So what you take note is, now let me verify. So point C, okay, is the position of the centroid for both y and z axis. Okay. So what you see over here is point P. Okay, point P is applied a certain distance. Okay, a certain distance away from point C. Okay, or on the Z, along the Z axis is applied at a distance away from point C, and on the Y axis is a B distance from point C. So for this case, you are going to have two moments. Okay, so you're going to have moment about Y axis. So I'll use a different marker. So you have a moment in Y axis. So moment in Y axis is equal to force times perpendicular distance, which is A. Okay, so what you see over here is over here you have a moment about Y. Then you have another moment. Okay, so you have another moment in Z. So this will be equal to P multiplied by B. So the moment will be acting this way. Okay. So for this case, and for this case, your formula will look like this. Okay, so stress X is equal to Px over A, okay, plus by My over Iyy multiplied by Z. And like the method I teach you all, it's not necessary to know whether it's a positive or negative for now, because later on we will know how to compensate. So if I were to follow the formula by right, this should be minus mz over izz multiplied by y. Okay, so over here, this is due to the axial load. Over here, this is due to bending moment about y-axis. And over here, bending moment about z-axis. Okay, so it's pretty straightforward. Okay, so I will now do an example. Okay, this is best done by example. Okay, so we're going to do our example. Anything to say about this formula? No. Okay, so let's look at example number 1 for today. So for the loading shown, determine the stresses at point A and point B. Okay, so we have to determine the stress at point A, point A. And the point where the neutral axis intersect line A, B, D. So we are asked to identify the position of the neutral axis. Okay. So first of all, we're going to draw our transformation. So this is our X. This is the direction of our Y. And over here, this direction is our Z. So over here, we know, okay, what we know is we have px. So the structure okay, is under the loading of px, moment about y, and moment about z. Okay, so from here we are able to identify that this is a eccentric. Okay. The eccentric is due to px over a. Okay, this is the one causing the eccentric loading. Eccentric unsymmetrical loading or bending. And the unsymmetrical bending is because of my over Iyy multiplied by z and mz over Izz multiplied by y. Okay, so that is a contribution of the unsymmetrical bending. Okay, so from here, now I have developed a way of solving this. Okay, you can see that this is actually a 3D problem, but our pen and paper or our paper is in 2D. So you have to put them in different view, then you can visualize better. Okay, so let me elaborate what I mean. Okay, so now you are going to view it from this point of view. Okay, so this will be your, I'm going to draw our transformation so no one get confused. So this is your y, this is your z, you have your rotation about x. Okay, so we know that we have load coming towards us. So this is 150 pounds. This is 500 pounds, right? And this is 250 pounds. Okay, so from here, we can immediately write down that we have a px will be, oh, I beg your pardon. We can immediately write down that px is equal to 150 plus by 500 plus by 250 is equal to 900. Okay, why plus? Because if you look at the 150, 500, and 250, it's going to induce what? Tensile. Okay, so positive because it's going to be tensile. Okay. Then the next thing that we're going to do is we're going to find our moment about y. Okay, let's do the moment about y first. So let me fill this up. So I'm going to draw the position of the neutral of the centroid. Okay, so this is one. Okay, and I think I'm going to select, and I'm going to copy because I need two of these figures. So the first thing we're going to do is we are going to calculate the moment in y. Okay, we're going to calculate the moment in y. So my moment in y, okay, I'm going to sketch this out. So we are going to determine the moment in y, and this direction will be positive. Okay, that is the assumption that I make. Okay, that we make. Okay, so later on when it's negative, we just need to flip the direction over. Okay, so moment, so positive is going in this direction, right hand rule. So moment in y is equal to, so now this is where we are taking moment in y, and you have to know the distance from here to here. This is 2 inch. A lot of times students make mistake with this distance. Okay, so we know that this is 2 inch and this is also 2 inches. Okay, so from here we know moment about y is equal to 150, so it's going to be in a in a anti-clockwise direction. So it's 150 multiplied by 2 plus by 500 multiplied by 2